modern market of building materials every year offers new types and varieties of materials, including finishing. One such material is a wood gypsum composite. It uses gypsum binder of G16 grade as matrix. Second grade pine sawdust with a fraction of 5 mm acts as a filler and is designed to reduce the cost of making the product, as well as improve the thermophysical characteristics of the material. Also, the use of wood sawdust in the production of composite material partially solves the issue of their disposal. In the course of experimental studies, it was found that the optimal composition of the wood gypsum composite is the following composition by weight: 45% gypsum grade G16, 16% second grade pine sawdust with a fraction of 5 mm, 39% water. Due to the fact that the developed wood gypsum composite is a new material, it is necessary to study its characteristics, including composition. To determine the moisture content of the wood gypsum composite, a gravimetric method for measuring moisture was used, which is based on determining the mass fraction of moisture in the material. The method is versatile and highly accurate. The error of the method is due to the probability of incomplete removal of moisture from the sample, as well as the removal of volatile components or oxidation occurring during drying. The main drawback is the duration of the measurement, from 5 to 15 hours, sometimes more. To determine the moisture content of the wood gypsum composite, an NML50 device, moisture meter, was used, the principle of which is based on the analysis of moisture that evaporates when the sample is heated, thermographic method. Thus, air heat drying of weighed material weighing up to 50 grams takes place to equilibrium with the environment, removal of moisture from the sample. The device consists of analytical scales and a drying cabinet. The study was carried out according to the following program. 1. Heating a sample of wood gypsum composite to 250 degrees. 2. Holding until weight loss ceases for 15 minutes. The specific surface area of the wood gypsum composite was measured using the Brunner-Riemann-Teller method using an AutoSorb IQ Station 1 high-performance gas sorption analyzer. The Physicorption/Chemisorption micropore analyzer, Fig 2, with 3 micropore analysis stations and 4 specialized built-in ports for sample preparation, Gypsum. The Brunner-Riemann-Teller specific surface is the most common method. It is worth noting that a number of assumptions are used when applying the method. The first assumption is that the adsorbent surface is uniform. By adsorbent is meant the phase on which adsorption takes place, i.e. the phase which will form the surface. A second assumption is that the reaction in the adsorbate-adsorbate system is weaker than in the adsorbent-adsorbate system. By adsorbate is meant a substance which is adsorbed. The third assumption is that the interaction of adsorbed molecules is only taken into account in the direction perpendicular to the surface and is considered as condensation. To calculate the surface area of the adsorbent, the gas volume relative to the monomolecular layer and the cross-sectional area of the adsorbed gas molecule are determined. The accuracy of measuring the surface area with such a device is about 90%. The moisture content of the material was determined by the gravimetric method on the moisture meter NML50 program, heating the material to 250 degrees and holding until the weight loss ceases for 15 minutes 26.3 plus or minus 1.2%. The total pore volume of the wood gypsum composite of the optimal composition is 0.016 cm3/G. The DFT report is shown in Figure 3. The histogram of the distribution of pores of the wood gypsum composite of the optimal composition is shown in Fig 4. According to the studies, the specific surface area of the wood gypsum composite was 9.9 m2/G. The results of the Brunner-Riemann-Teller method are reported in Fig 5. Elemental analysis of the developed wood gypsum composite was also carried out, which made it possible to carry out qualitative detection and quantitative determination of the elemental composition of the material. Studies were performed on 2 samples. Elemental analysis showed that the developed wood gypsum composite is more than 98% composed of Ca and Sx in a ratio of 65.23 and 33.23%, respectively. In addition, minor amounts of Fe, senior, Px, up to 0.1% each, and Si, Ti, Mn, up to 0.01% each, were found in the material. Thus, the moisture content of the wood gypsum composite is 26.3 plus or minus 1.2%. Total volume, 0.016 cm3/g. The specific surface area of the wood gypsum composite was 9.9 m2/g. The wood gypsum composite is more than 98% Ca and Sx.